think we will speed things up and talk a little bit about chaos and observability and Kubernetes. My name is Michael. I go as DNS Michi, which is a little hard to pronounce in English, which is DNS M-I-C-H-I. I got that nickname like 10 years ago when I was working in Vienna at the university, and I couldn't get rid of it after a while. But it's not about me today. It's like what should you expect in the next couple of minutes? Some stories from an open source monitoring maintainer. I was in the past diving into metrics, Prometheus, Grafana, Kubernetes, some things about alerts and the service level objectives. And then we're diving into chaos with Kubernetes, talking a little bit about DNS again, chaos tracing, and some ideas and stories around beyond observability, open telemetry, and obviously you might find some Lego images between the slides, so you might catch them all. And I want to start with some ops stories on like how do we approach. We have Kubernetes up and running. There is the architecture. There are many components. There are many names to understand. It's nodes, pods, containers, deployments, services, APIs, ports, data sources, and then my knowledge ends at some point. And the question was like, how could I like monitor that? Or what is important to me? And someone said we need monitoring. So okay, maybe availability monitoring or something like that, or some performance and resource monitoring. And we want to identify slower blocking deployments. Now, the classic host service model with state-based pulling and something like that doesn't really apply to microservices. So we might be looking into metrics, logs, even more. Do we need to understand all the components which are running to really feel that everything is working? Maybe, maybe not. What are the best practices? And it can get overwhelming, so we really need to figure out what is important now and what can be done later on. So in the first iteration, it's now like Kubernetes has many different data sources. We can use service discovery. And within the CNCF ecosystem and wider community, I found Prometheus, the metrics endpoints. It has a time series database. You can calculate trends. You have dashboard service level objectives. And from there, it's easy to go to alerts and incidents. A little bit about Prometheus itself. It's a huge picture. The most important thing is we have the Prometheus server, and it allows us to query Kubernetes by service discovery and being able to monitor certain things. You can play kind of Lego and tack many things on top. But we want to focus really on Prometheus and also keep in mind it has a strong query language or like a feature-rich query language which allows us to calculate the metrics and the data we want to use. We can present it, we can consume it using an API, and the format is pretty much, I wouldn't say self-learning, but it's straightforward to really get an insight pretty fast into your monitoring. Now, from the UI side, you might know that there are Grafana dashboards, but Prometheus also has a UI, most recently pretty much improved. And one of the other things I recently found was Persis, which is in development at the moment at the CNCF, which is dashboards as code and could help automate certain things even more. Coming back to like Kubernetes and Prometheus, the Prometheus operator is a feature-rich operator, and it also provides Kubernetes on top, which allows you to deploy Prometheus, the node exporter, the alert manager, Grafana, and also certain best practices around alerts and dashboards, which is awesome because you can immediately see something, and it's not just monitoring is deployed and it's empty. Now, what exactly will we be seeing within the Kubernetes deployment? It will be lots of metrics. We do have cluster metrics for the node status, for the resource usage, for the deployments, number of pods, network, and even more. So at some point, it has gotten quite overwhelming looking at all the dashboards, but it's great to have them. So you can analyze them. You can see whether you want to use, for example, the container metrics, the kubelets provided CAdvisor exporter, for example, and get insights how the containers are using the CPU usage, how memory is being used, and so on. The other thing to mention is Kube State Metrics is also a project which gets automatically deployed to figure out the health of the deployments, nodes, and pods. Many different ways are being abstracted, so you don't need to reinvent the wheel doing the monitoring. You can just use that, and it's installed by default. Now, when we think of defining service-level objectives or SLOs and alerts, we need to figure out, well, metrics are nice, what's next? So like we want to define the definition of failure. We want to do something because maybe a threshold has been violated, a rule has been matched, so we want to notify and raise an alert. The who is potentially everyone. No, it should be a responsible team and identified personas. And also, it shouldn't be just like an alert and say, yeah, it's nice, but acknowledged and go away. But you want to really act on that and provide documentation for incidents, runbooks to fix problems, to analyze things, and maybe even define like corrective actions within the incident. And the other thing is to keep in mind to iterate on every incident and everything which happens, like reducing the mean time to response or resolval. Depends how you want to abbreviate it. When we think of alerts with Prometheus, there are two ways, like Prometheus alert rules, sending them to the alert manager, and the alert manager allows you to do some grouping, some inhibition, some silencing, which means kind of acknowledging things for a given time. And then you can send the alerts to specific endpoints, APIs, email, classic, or pages, or other ways to notify about things. Now, for Kubernetes, there are some alerts defined by default by the Prometheus operator, Kubernetes. I've also found a website which is called awesomeprometheusalerts.grep.to, which has many, many more best practices, and you can easily like copy-paste them. You should like inspect what you really need, but it can be helpful to define infrastructure alerts for memory, CPU, and even disk pressure, ports, error rates, and also reachability, for example. This is a lot to like understand and to know. The way we can integrate it into the Prometheus operator is there is a so-called Prometheus rule custom resource definition, which allows you to wrap the Prometheus alert rule into the Kubernetes YAML format. And this can be helpful to really like deploy everything in one format and not just have 5 different ways to configure things with your Prometheus. Now, for the alert receivers, a chat can be something like, I want to immediately see something, but oftentimes it's really needed to refine things and think about grouping and not have 500 alerts being flooded in your inbox at 3 a.m. in the morning and you have no idea what's going on, but you still need to fix the problem because the customer is calling. Maybe you want to like use external ticket or issue systems to have a way to consolidate this for everyone, maybe mailing lists even. And the other thing is like also to think about that you might get tired of too many alerts. It's alert fatigue, I think it's pronounced. This is often something which can lead to burnout after a while. So it's really important to think about what should be actually alerted and not just be a notification number in your inbox, which is 20K unread or something. Yeah, and the thing is, how do we get these alerts? So by default, everything is working and oftentimes you don't see anything. Now we can trigger alerts manually by killing a pod or doing something, but like manual work is a bug. So there are probably better ways to cause some chaos in the Kubernetes monitoring. You might be using kubedoom to kill some pods in a fun way, but I'm not sure if that is allowed at work. But it's still an interesting project to try out and see whether alerts are working or not. The other thing is then, on a more serious note, like simulating a production incident. This is really hard. Like I can break something, I can break DNS and see how everything is like not working. But in the end, you want to like add some sort of automated chaos on a schedule, on a cycle, on a way of also using it in a staging environment, but also in a production deployment, testing in production. And the idea is to really trigger alerts and service level objectives to see that everything is working as expected and you can react on that. Now, this brings me to observability and chaos engineering, which is kind of, you can do it the boring way, like the German chaos, or you're looking into like cloud-native deployments, chaos frameworks, chaos experiments, and so-called instrumentation SDKs. But I still like the German chaos. But yeah, the idea is really to use a framework. And one of these frameworks I found is in the CNCF community is Chaos Mesh. There is also Litmus Chaos and some other projects around this area. And it's easy to fail Kubernetes, nodes, pods, whatever, or even hosts in your cloud infrastructure. And you can play around with like reducing the network or failing the network, failing HTTPS or making it slower. Playing around with time, which is quite interesting. If you maybe know Nagios from 10 years ago, cannot reschedule a check because time is not in sync. Or maybe even DNS, because when something is not resolving to an IP address or giving a wrong response, the application might do something weird, or the deployment. And from a user perspective, Chaos Mesh allows you to run experiments like once, you define it, or you can also use it continuously as a schedule, which can be helpful that you say you want to test it every day in the morning at 9 a.m. and see how it goes. Probably not on the weekend. The first steps in generating some chaos can be to kill not to kill some pods, to fail some pods in a more gentle way. And the shown screenshot kind of forces the pods to fail. And Kubernetes detects that after a while as a crash loop back off. And okay, this is kind of expected, but is this sort of like the real chaos I really want to see? And so I was like, maybe we should dive into more practical examples rather than trying to click in the UI and do something. So I was thinking of maybe turning back time a little bit when I was a developer, and we wrote a distributed monitoring application. And only when DNS was failing at the customer environment, it leaked memory and caused some other troubles. And we as developers, we were not able to reproduce that. And it was like, fix this. No idea. Okay, then fixing the code, pretending it worked, releasing it, and letting the customer test in production. This kind of turned into an endless burnout cycle. But in the end, it was it was a good experience to learn and say, hey, there are certain scenarios I cannot even predict they would happen in a production environment. And it got me thinking of, well, maybe I can write a short application which simulates that behavior, just using a receive buffer, which is like 1 megabyte, and we're doing some DNS resolver, and we're handling all the errors, and we're not freeing the buffer, so we are leaking this problem intentionally. Now, the thing is, then I talked about this in our Everyone Can Contribute Cafe meetup, and Niklas was like, yeah, I have my own chaos. I can like scale core DNS to 0 replicas, and was like, oh, I didn't know that. Interesting. Which is one way, which is a cool way to fail everything. And it got me thinking, but yeah, how can we do that with a more automated way and only failing certain things in this scenario? So with Chaos Mesh, you can automate this kind of DNS failure and say, I want to choose the type DNS chaos for that thing, or for that experiment, and the action should be error. You can also choose random, which provides some random IP addresses as a response and see what's happening. And the other thing is you can use selectors for namespaces and labels, of course, and the patterns. So in this example, I'm checking specifically for O11y whatever, and also for ContainerDays. So I was actually looking into a demo some hours ago to really make this fail. And looking at time, I think I'm good in time. I can do the demo. I want to do the steps with you together now. And one of the things is I do have, oops, maybe I'm making a little, this didn't work for some reason. I do have some ports, hopefully, yeah. And we do have the ContainerDays port and logs follow. Yeah, and this one is actually resolving things. Then I need to make sure this is, the port forwarding is currently not working. Okay. We do have a chaos experiment over here in chaos mesh. So over here, this is something I created a while ago. And the idea is now to start the experiment and see whether we can fail DNS for this port. Should be starting soon. The other thing, meanwhile, while the experiment is running, we do have the Prometheus query for the container memory usage. And this is currently something like 300 kilobytes, 200 kilobytes something. And when the experiment is starting, this should go up actually. Let me see. And hopefully the demo. Hopefully this works. Otherwise, I have some screenshots from before, so we need to pretend it worked. Yeah, it should be. It should be working. Yeah, probably. Let's create one from scratch. This should be the DNS schedule for ContainerDays. So you can also write it the same way as I did now and just create a new schedule. And you can just upload a YAML definition, for example. Submit it. Everything gets pre-filled by default. And just call it CD now. And force it to run. Okay, now I have 2 experiments running. And if it doesn't work, yeah, then I blame it on the Wi-Fi. No. Maybe I'm looking at the wrong. Okay. I will be getting back to that in the end of the talk. The thing is, or the thing I wanted to show you is that the container memory usage is going up. And I've defined an alert or a service level objective for 10 megabytes, and everything goes up. And the chaos experiment is running, like in the screenshot. And before doing so, I've also defined an alert, which triggers, and you can see it in the alert manager. So this is a screenshot from 1st of September. I also have one from today, well, yesterday. The idea is really to like trigger an alert and see that something is failing just because it leaked memory. Now the thing is, when you're generating lots of alerts and lots of things in your Kubernetes cluster and generating alerts, you might need grouping, you need additional context. You also need to focus on the dashboards because the Kubernetes provided dashboards, there are so many of them that it might be needed to reduce the amount of data, correlate certain things, and also provide more context to really provide actionable insights into what's going on, because when everything is burning, you really need focus and want to fix things fast enough. To gain confidence and really look into things, there are many ideas, points already available. We have metrics, we have the values, we can create PromQL queries for alerts and service level objectives. For ops, it's still valuable to look at the golden signals defined by the Google SREs, like latency, traffic, error, saturation, to get an immediate insight whether the deployment is healthy or the current cluster. The other thing is document everything, think about customizations, also think of onboarding, because when someone is joining the team and they don't really know about the current state of observability in Kubernetes, it can be really hard to understand and get into the loop, basically. And the goal should always to immediately see what's important during an incident. When you look into customization for Kubernetes, you need to learn JSONnet, which can be done. You can develop your own rules and dashboards. You can monitor other namespaces, add applications, remove applications. If you don't want to use Grafana, but something else, for example, can do that. I've looked into the previous example of the container memory usage. This can be defined by adding a Grafana dashboard, defining the data sources, using the PromQL query, and just have it configured in one format and deployed into the cluster. Another advantage, another confidence thing is with Prometheus, Prometheus automatically scrapes HTTP endpoints like the /metrics endpoint. When your application provides a service monitor custom resource definition, Kubernetes picks it up automatically, and you don't need to think about, hey, I need to configure a host or service or the metric, but instead everything works with auto-discovery, which is also a quite nice way to do that. Now for a moment, we've talked a lot about metrics, but observability is beyond metrics, and there are certain event types which we certainly see, like logs. We have maybe traces, profiling, error tracking, even more event types. And then we're thinking about, is this observability? Yeah, maybe we want to have the look from above and see things which are the unknown unknowns, like DNS is leaking some memory, or something else is causing a failure, which we haven't been aware of yet. We never would have expected it, for example. For logs, I've read many things. I've evaluated many things myself. There are many different opinions as well. For a central log management solution with Kubernetes, you really need to figure out what is important to you. Is it helpful to have a retention of logs for 1 year and pay, I don't know, $1 million or something? Or is it just needed for live tailing or for the past day when the incident happened to analyze something? There are various options available. This is just a random list of vendors and tools which you can look into. But in the end, it's really up to what is needed to solve the problems, rather than keeping the logs forever because we have endless storage, which we don't. The other thing, which is, in my opinion, a little more interesting, is to look into tracing, which is a trace is like a log, but spans with start and end time. There is a context, there is metadata enrichment. And the thing is, even if I need to learn it in a way of adding it to my code, or as a developer I need to add it to the code, there are also ways to use auto-instrumentation. And it helps providing a few and distributed environments with many different microservices and sources and ways how the client response gets calculated in the backend. So this can be really helpful looking into tracing. One of the things which evolved over time, and I will only touch the surface now, is OpenTelemetry as a specification and a framework which is beyond vendors, so everyone is working together on a specification. It's a collector and can also be run as a sidecar. And the idea is to bring your own backend. So if you want to store metrics, use Prometheus. If you want to store traces, use Jaeger tracing. And on the other side, the client libraries in the ecosystem is very feature-rich. So there are many libraries already available or in development, and even our instrumentation is available. So if you want to learn more, I would recommend checking out Dotan's talk and Lightning talks tomorrow. I think he's an expert in that area, can answer many questions. For now, for me, it's the focus on traces. So in Kubernetes, the components can send traces. There are certain patches upstream already available, which you can enable. And the application can get instrumented with traces, being sent to the OpenTelemetry collector, stored in Jaeger, and we can use it to visualize, correlate, and alert. Why would I be doing that? So one example could be like the client requests some data from an HTTP server. The server asks the backend, queries some APIs, collects the data, creates a client response. The idea is then to instrument Nginx and Apache as a web server to see the traces. You can use, for example, the OpenTelemetry web server SDK and send the traces to Jaeger, which shown in the screenshot. It got me thinking, how can I add chaos to that? Because I really want to see that the traces are getting longer because something is going wrong. So I thought of, well, maybe add some sleep functions in my code and then deploy it, and so that nobody sees it behind a feature flag. I was like, no, that's crazy. Shouldn't be doing that. Better think of a chaos experiment for like HTTP network, or even put a stress test on the node or the pod to see what is going on. And one of the things I did in the past week was to use Chaos Mesh to stress test the CPU and memory of a specific pod for this OpenTelemetry Nginx service. And I could see like the trace time was increased by 5 times or something. Still, it was 2 microseconds to 2 milliseconds to 9 milliseconds, but it was a certain increasement. And the idea which I got from that was, hey, we can link metrics to traces. So when something is breaking in the system and we see the graph going wild, maybe it's helpful to see the traces. The other thing is, at KubeCon, there was a talk about the future of Jaeger, and aggregated trace metrics were mentioned. So you can create metrics from traces received in OpenTelemetry. So we can, again, add alerts to the metrics and add chaos to that to see what's going on. And the other thing is, like I mentioned before, traces for Kubernetes system components, which is also a thing with Kubernetes. Now, long story short, there is so much more to talk about, even beyond observability. Just want to pitch some ideas to you. What else is coming or coming soon? And it's important to maybe have a look at. We're talking a lot about eBPF, which also allows to perform observability on the kernel level or on specific syscall events, using it for observability, but also security and other things. And the thing is, how does it fit? How does it fit Prometheus metrics? Can we integrate that? Does it complement itself? How do eBPF, service level objectives, alerts, and chaos engineering work together? Also because Cilium open source Tetragon at KubeCon. And I thought of, well, I only have 35 minutes today, but I will be building future talk stories and demos and other things for that. So we need to learn and learn and learn. Now, the other thing I want to bring to your attention is hacking Kubernetes. So the security parts and thinking of impersonating the attacker, and maybe use chaos engineering principles for pen testing. I'm talking too much. Yeah, and maybe have observability for better security in that regard. Now, finally, confidence is looking at a nice Lego picture. That's something from my living room, actually. Define different scenarios for chaos engineering, for chaos testing. So for SREs, for DevOps, and even DevSecOps. And for your own chaos, you should know the limits of chaos. So avoid chaos inception. It doesn't make sense, or you shouldn't be running all experiments all the time, because it can harm existing workflows and teams. Maybe use staging environments to prevent data loss. And also think of that chaos engineering doesn't solve all the reliability issues, but it can help with new perspectives. And I'm keeping it short because I'm losing my voice already. Continuous observability, think of your workflows, CI/CD with merge requests, and there use chaos engineering and metrics and observability in there to get feedback fast and avoid the DNS errors I made 10 years ago. Or think of continuous delivery and run chaos experiments in production. And last but not least, bring confidence with chaos, bring chaos into observability, chaos workflows, alerts, iterate and innovate. And the last thing is maybe combine machine learning and chaos engineering, which would be fun, maybe Skynet in the future or something. But yeah, many ideas, many great things to learn. And if you want to learn more, I would recommend checking out Dotan and Matthias' talks and many more tomorrow, which dive deeper into observability. And I have a newsletter, and I also have new GitLab stickers if you want some later on after the questions. Thanks for your attention.
Maybe some water might help.
Oh.
Drink something, please.
Thanks.
After that talk, and then join me here in the center for the questions. I need to brighten my phone a bit. We have 2 for now. Let's start with the first.
Can I use the CRDs of Alert Manager with an external Alert Manager? I don't want to miss any alert if my cluster goes down. One thing you can do is you define the Alert Manager allows you to define webhooks, for example, or a different transport. And it should be doable if you just configure the external webhook with your PagerDuty or something else and move it from there. But you can ping me on Twitter if you need more information about this.
Okay. And are there any OSS alternatives of Grafana for visualizing Prometheus time series data?
I'm hoping that the Persis project, which I showed, so it's github.com/Persis, where there's like work underway. It's Apache version 2.0 licensed. It's not HGPL like Grafana is now. So I'm really looking forward to see progress. And I think at KubeCon North America, there will be more updates in late October. I will be there as well. And like follow the project, I would say.
Okay. Can you elaborate on the new Prometheus dashboarding capabilities?
I don't know if that's really like dashboarding already in the UI. So like the Prometheus UI was replaced. I think it's React-based right now. And there is like a basic view on metrics and you can query with things. I'm not sure how far they will be going with dashboarding or focusing on the aforementioned Persis project. But I'm looking forward that someone builds an alternative to the almighty Grafana, to be honest.
Okay, we have 2 more questions. We will do those 2, and then we are at the end of the session. Can you use Kubernetes drift detection to move the cluster from an unhealthy to a healthy state?
That's an interesting question. To be honest,
you don't know?
I don't know, but I think it's. I will look it up. Yeah, it's a great idea. Thanks.
Okay. And the next question that came was, is there any plan to have auto-remediate feature from alerts?
I'm not sure if this will like happen within the Prometheus operator project. I'm pretty sure that vendors who integrate with Prometheus or provide an observability platform or DevOps platform or whatever, that they are thinking of this. I've seen that the term AI ops is coming back within observability, so that we get assistance with many metrics, with observability, and also with alerts. And maybe in the future we will see some things like you're writing your code in GitLab, and then it gets deployed and observed, and some AI says, hey, you should be fixing this, and by the way, here's the merge request with the diff, you can review and apply it, something like that.
Okay. We have one last question. Are you ready for this? Let's see, drink another sip of water. How do you coordinate test runs with chaos scenarios?
Probably you shouldn't be doing tests when your chaos experiments are running. But on the other side, it would be interesting to see. I would make sure whether you want to have all the teams informed and know about this, or you go the security way of pen testing and say, we are the red team, we don't tell anyone, and we're just deploying a chaos experiment and see how things are going. I think like damage control and estimating what could go wrong in production is really important, to not have like 10,000 of euros wasted by chaos engineering. That's not the idea behind it.
Thank you so much.
You're welcome.
I also have a card deck for you.